Hello everyone, welcome back to the channel. So in this video, we are going to implement a hash table by ourselves. Okay. For that, I'm starting with the method of put, you know, the method that we use to add a key value pair. Okay. So without wasting any more time, let's get into the implementation. While understanding what a hash table is, we understood the concept of an entry, right? So if you want to so whenever we want to add this key value pair in the hash table, right, we need that entry. So let's create that class first. Okay, private class entry. Now entry is, consist of your key and your value. So I'm taking integer, I'm taking key as an integer and your value as a string. Let's add a constructor there. Okay, int key string value, this dot key is equal to key and this dot value is equal to value. Now that this should be entry. So now that we have an entry class, right, let's understand what is the implementation that we are going to use for our hash table. So in our last video, we talked about two concepts, that is sharing and open addressing, right? So as part of this implementation, we are going to utilize the concept of chaining, okay, where we are going to take the array of a linked list and we'll keep on adding the element at the end of the linked list whenever there is a collision. Okay, so every new item we will be adding at the linked list at that particular index. Okay, and if there is a hash collision, the collided object will be adding at the end of the linked list. How we are going to do that, let me show you. So let's take a linked list first. Linked list of entry, this is an array of linked list. Entries is equal to new linked list array. Let's take a size of 5. Now let's create a put method which will take a key value pair, okay, and which will add to this entries or hash table, this linked list array, which will add to this linked list array. Let's get into the implementation of the method. Private void put int key string value. Now what is the first thing we want to do? First we want to check if your entries of that particular, okay, first we need to calculate the hash index. Okay, how do we calculate that? Index int hash is equal to hash of the key. So to calculate the hash value, we need to pass it to the hash function, so that whenever we are getting that hash, at that particular hash we'll be checking if the linked list is already there or not. If it is not there, we'll create a new object or we'll just add the element there. Otherwise we'll add the element at the end of the linked list. Let's implement that method first. Private int hash int key, this will return key mod entries dot length. We are doing the mod because we want to keep all the values in this limit only. We have decided we are going to take 5 size of this linked list array and we'll be storing elements, all the elements there only. So let's check this hash. Okay, if this is null, that means at that particular index in this linked list array, that linked list is not initialized. Okay, this null is signifying that that particular linked list is not initialized. Then what we are going to do, buckets, okay, entries of hash is equal to new linked list. Okay, now linked list. Actually we can take this in a variable for a better naming convention, so better readability as well. Linked list of entry, let's call it a bucket, and bucket is what we call in the actual terms of hash table also. So bucket, which is this entries of hash. That's perfect. Now what we need to do, now we need to just add that particular element at the end of the linked list. New entry, let's take the key and the value. Now there is one problem which is still there. Whenever you're trying to add the value with the same key, right, it will consider it as a new value and it will add it at the end of the linked list, which we don't want. For the same key, it should update the value at the existing key. It's not supposed to add it. So for that, what we need to do, let's create a loop there for each of the entry. Okay, I'm calling it ent for, okay, let's call it entry. For each entry, what we want to do in this bucket, we want to check if entry dot key is equal to the key that we are passing. If that is equal, then for that entry we just want to update the value. Okay, and the moment we update the value, we want to return the control from there itself, so that we don't go ahead and add another value for it, another entry for it. Okay, I think this implementation makes sense to me. Let's try having a demo of this so that we know that our implementation, whatever you have done, is correct. So let's create a main method there, alpha hash table is equal to new hash table. Okay, now for this hash table, let's add a few values there. 1 comma, let's add some big names here. Bill, let's duplicate this. 2, 3, and then in the end we will be again replacing some values. So Bill, Steve, Larry, and Sundar. All these very big names in IT. If you don't know, this is Bill Gates, Steve Jobs, Larry Page, Sundar Pichai, obviously. So what we are doing here in the hash table, so we are putting these key value pairs in the hash table. For first key we are putting Bill, for second key we are putting Steve, for third key we are putting Larry, and again we are updating the key for the one number with Sundar with a new name. So let's, if I want to show you, if I print this directly, right, hash table, you won't see anything. You'll get some hash code, but you won't get a a visualization of how, if the things got added properly or not. For that, let's try running this in debug mode, and we'll see if our hash table is populated properly or not. So we are supposed to have 3 values in our hash table, and at the one, for the one key, we are supposed to have this value, not this value. Okay, let's see that. So we, okay, for our entries we have 3 values, which is correct. For third we have Larry, which is correct. For second we have Steve, which is also correct. For one, if we are checking, we have Sundar. You see, we have this value, okay, not this value. Now let me show you one more very interesting thing. So let's say in case if the collision happens. So now I wanted to show you one more scenario where we are adding the element at the end of the linked list. Okay, in case of collision. Okay, so let me show you how we are doing that. In case of collision, I have added, let's say, these 3 value at 6, 8 and 11 index. Let's try and see if it is, whenever the collision happens, it is adding value at the end of the linked list or not. So at the 0th index we have Larry, and at the first element we have Elon. Okay, so this is where the collision happens. That's why we added that element at the end of the linked list. Okay, here there was no collision, so it added straightforward, right? So this is what I want to show you in, what happens in case of collision. So I think this is good enough for a single video. We have seen how we are implementing our entry class, how we are creating that linked list array where there is a chance of collision happenings, how we are implementing our put method, okay, where we are utilizing the concept of bucket and chaining. Okay, chaining means whenever there is a collision happens, we are adding the element at the end of the linked list, and that's what we have seen while adding these elements as well. So yeah, that's all I wanted to show you as part of this video. Just practice this and see you in the next video. May the source be with you.